Okay, so guys, now in this video we have to differentiate sine root 1 plus 2x divided by 1 plus x. And whenever we are given a root, we have to make it equal to power 1 by 2, right? So the root is actually equal to power 1 by 2. So we can simply, first of all, let's consider this function as y. And then we can write this thing as sine 1 plus 2x divided by 1 plus x power 1 by 2. Okay, and now I can continue by applying the differentials on both sides of the equation. So dy by dx is equal to d by dx sine 1 plus 2x divided by 1 plus x power 1 by 2. We are dealing with a sine function, and the derivative of sine x is actually equal to cos x, right? Along with the differential of the angle. So over here we have sine 1 plus 2x 1 plus x. So we can write it as cos 1 plus 2x divided by 1 plus x power 1 by 2, and now the differential of the angle. Now what is the angle? We know that x is the angle, so if over here for this case the angle would be 1 plus 2x divided by 1 plus x power 1 by 2. So the derivative of 1 plus 2x divided by 1 plus x power 1 by 2 multiplied by, and now if you see over here, this function is actually an exponent function, right? So wherever we are finding the derivative of a function which is having an exponent, we have to deal with the exponent in such a way that we have to separate it. So the exponent would be at the beginning, then the function 1 plus 2x 1 plus x, okay, and then the function minus 1. So 1 by 2 minus 1 would actually be equal to negative 1 by 2. So the power would be over here. And now again, the derivative of the angle for this thing. Now the angle in a function is anything which is present under the exponent. So this would be my angle right over here. So again, the derivative of 1 plus 2x divided by 1 plus x. So I hope that makes sense. Let me just give you a general formula for that. D by dx, we are having f of x n, then we can write it as n f of x n minus 1, and the derivative of the angle. Now what is the angle? It is x. Okay, so this is the general formula for dealing with any function which is having an exponent. So these two terms would be as it is, but yeah, I would like to do one thing over here, and that is I'm going to reciprocate this term because it is actually having the negative exponent, and if I reciprocate the terms present inside the exponent, the power, the exponent would be positive. 1 plus x, 1 plus 2x, power 1 by 2. And now this is the old division formula. We can use the division formula for finding the differentials. So the second function as it is, the derivative of the first function minus the first function as it is, the derivative of the first function divided by the square of the second function. Now this is my first function, which is fx, and this is my second function, which is gx. Okay, so these terms would be as it is. So 1 plus x, the derivative of 1 is 0, and the derivative of 2x would be 2 minus the minus 1 plus 2x, the derivative of x would be 1 divided by 1 plus x whole square. Okay, we have 2 plus 2x minus 1 minus 2x, because the negative sign would be multiplied by every term present inside the bracket, divided by x whole squared. So this 2x and this 2x would be cancelled. 2 minus 1 gives us 1 divided by, and now I'm going to reciprocate this 1 plus x whole square, so it would be 1 plus x negative squared. Why? Because if you see over here with this term, if I separate the powers, I will get 1 plus x power 1 by 2 and 1 plus 2x power 1 by 2. So you can see over here, this is 1 plus x and this is 1 plus x. When the bases are same, the powers will be added. Okay, in the denominator we have the same thing, 1 plus 2x power 1 by 2, and over here we have 1 plus x, the bases are same, the powers are added, so 1 plus x 1 by 2 plus minus 2. So we are getting 2 negative 3 by 2. So the final answer would be, and so I'm getting 1 plus x minus 3 by 2. Let's just rewrite this function in a much simpler form. So the constant would be at the beginning, and then the trigonometric function, and then I can actually reciprocate this thing because this is again the negative exponent, and when I will reciprocate it, it will become positive, multiplied by 1 plus x power 3 by 2. So this would be the final derivative of this question. Okay.